Hi, welcome to the Calculus 3 problem solving sections. So today, this video, we're going to take a look how to do a line integrals and over the given plane curves here. That means the curve is in the XY planes here. All right, so before we do it, let me write down the formulas we talk about how to do the line integrals here. So, okay, here we go. So, okay, so we set the curve here. So if I have a curve C, then I have a f of xy and the ds here. All right, so this is we integrate according to the arc length here, right? The ds. So, like we said before, be careful about so this is a ds, it's like this is a ds. So, what do we do here? So, we know the formulas here is, you need to find the parametric equation for your curve. So we do here is the C. So here this is f of, we have xt, yt, right? So we replace the parametric equations here. And then here we have a dx over dt to the square plus dy over dt to the square times dt here. Then here is changed to the range of the t. All right, so for this ones here, we are doing this curve based on the plane given curve for the problem number 1. This one is pretty easy because the parametric equations already given here. So I know the x equal to t3, y equal to t4. So I know the the dx dt will just be what? The dx dt will just be 3t the square, and the dy dt, okay, so will be what? 4t cubed here, right? Then the whole this line integral, we can just try to change it to be a parameters t, so the range is from 1 to 2. Then I am going to replace it, right? So I'm going to replace this function. So I'm going to replace this function, xy, by my parametric equations here. So x is t to the 3. All right, so let's say here this is t to the 3 over t to the 4 here, right? And then the dx dt, so times the dx dt is 3t the square plus square and plus 4t the cube squares here. Now I integrate dt's here. So if you simplify a little bit, then this one will give you, this is 1, 2, and then this is a t, and the inside here, this will be 9t to the 4th, and plus 16t to the 6th dt here, right? So then the next thing is here, I can try to simplify it a little bit, so I can factor the t4 out. So make the integration is a little bit easier. So now let's continue here. So this is be 1, 2. When you take the t4 out, it will be t squared out, out of square roots, right? So this outside will be t cubed. And then here, the inside will be what? 9 plus 16. Then you take the you take the t4 out, you get a t2 inside here. Okay, so that's what you're going to have a t2 inside. This is dt. Sorry, I made a mistake. This is a t3 over t4, so it should be 1 over t. And 1 over t, when you take the t2 out, I did not pay attention here. All right, so here, when you take a t2 out, this will be a t by itself. And then this integration will become pretty easy integration back to the, you're back to everyone's like a calculus 2. You know how to do this simple one variable integrations here, right? So basically, this one's here, a simple U sub probably would take care of the things. So you can do a U sub here, and then you will say U equal to the 9 plus 16t squared, and then substitute back. Since this is a Calculus 3 class, I'm not going to go over the detailed integration process. I'll assume everybody in the Calculus 3, you know how to do a simple U sub. So anyway, so the final answer for this one, so you'll be able to substitute, and so final answer will be this one will be 1 over 45. So it's 1 over 48. I'm sorry here. So this will be 1 over 48. Okay, 1 over 48 and times 73 over square root of the 73 minus 125. Okay, so that will be the integration. So I assume it from here to here, basically you use your calculus 2 skill. All right, so the problem number 1 is quite simple. You just directly plug it into the formula. Okay, problem number 2, part B, will be a little bit, one more steps here. So the part B, they give you a C is a line segment from the 2, 0 to the 5, 4. All right, so how do I parameterize this curve, this line segments here? All right, so how do I parameterize that? So, like in the calculus 3, when we first start, we will define the line in the space, that's right? So first is here, we can extended to define the line in the R2 also. So the first thing here, if we take a look at these 2 points, right? So define the line. So let's take a look at the direction vector for these 2 points. So the direction vectors, remember, is x minus x, y minus y here. So this is my direction vectors, right, for these lines here. Right, so then we choose a point, then we use the parametric form to define my x. So we say x here, now I choose the point 2, 0, so I can define the x equal to the 2 plus 3t, and the y is equal to what? Y is going to be 0 plus 40 here. All right. Okay. So now let's take a look. So now let's take a look at what is my t value. All right. So because this is the point, start with 2, 0, going to the 5, 4. So t has to start with zeros, right? So when t equal to 0 is 2, 0. Then where the t end? So t will end at 1. So when t equal to 1, I have the 2, right? 1, I'm going to end it with 5. And so in here, then the next one's here, when the t equal to 1, y will be end at 4. So I know this is going to be my parametric equation with the bound here. So this is how do we parameterize a line segments here. All right, because we have this, then the problem becomes pretty easy. We can just take a look at the plug into my previous equation. Let's do a dx dt will be 3. Then the dy dt will be what? Will be 4 here. All right, so now this one's here, I can rewrite it to the general calculus 2 type of the integration I have here. So the t is from 0 to 1. Then the x, this is 2 plus 3t. correct? All right, then the y will be e, this is 4t, because, all right, so be careful here, this is what I'm integrating, the arc, length here, okay? So now what I need to times the dx dt square, so it's 3 square plus 4 square and the dt. So 3 square plus 4 square is 25, so take the square root is 5, so I can take this 5, put it in the front, right? Then here I have a 2 plus 3t, and the e, the 4t, and the dt. Okay, so then this integration is just so that this will now, in order to get the integration, we need to use the calc2 method again. So like in here, we're going to use calculus 2. So what with this is a polynomial and exponential combinations, right? So what type of the integration skill the technique we're going to use here? We can do integration by parts, right? So we can do the integration by parts here. So this integration by parts, so finally we can do here is, I think these ones here, everybody still remember in the calc2 we use the table methods here. So these ones here we say 2 plus 3t, and this is E4t, right? So we say this column we take the derivative. This column we take the integration. Right, so the derivative of this one is 3, and then the derivative of this one is 0. Continue to take the derivative, right? So the integration here, this is a 4e4t. Then the integration here is 16e4t, right? Okay, then we will use, what is the next things here? We want to add the positive and negative signs, right? So we say this is a positive and negative, positive. Then we do this, correct? All right, so now our final integrations will come out of the 5. Let's leave the 5 outside. So the final integration will be this number times this number. So it's 2 plus 3t times 4e4t here, right? Then minus, right? Minus 3 times, so minus 3, 16 e the 4t here, all right? And then what do we need to do? We need to plug in 0 and 1s here. Okay, so after you plug it in, so we will get our answer is 85 over 16 e to the 4th minus 25 to the 16th. Okay, so this one, the reason why I carry out the integration, just want to kind of review a little bit integrated by part, especially the table method. All right, so the next one's here. So this one we need to be careful. If we want to do the line, the integrals here, but now instead of the respect to the arc length, I'm going to take the, integrate with the x here. Okay, so now with the x here, so they give us these curves here, x equal to the y cubed here. So for this ones here, because I'm going to do the dx, right? So I can just directly take the dx here. The dx is what? It's 3y squared dy. So, okay, so now let's take a look at how do I change this integration. So e to the x, so I will say e x equal to y cubed, correct? Then the dx, I can change this one to the 3y square dy here. So see here now, this is dy. So I'm integrate respect to the y's here. So where is the y value from this point to this point, right? So my y value is -1 to 1. You see here, so that's why I'm integrating for this curve, but with respect to x, so I'm doing the dx. But so in here, I know that x equal to y cubed, then dx equal to 3y squared dy. The reason why I switch to the dy, because as you can see, now my integration is pretty easy because of y. So this is 3y squared, this is what? Y cubes here. So why this is easy? Now, because I can use a u sub, right? So I will say u is equal to the y cubes here. Then my du equal to the 3y squared dy. Wow, that's pretty good. So this integration, so this will be the EU and the DUs here. So right now I'm going to leave this the upper bound, lower bound. I will leave it open right now because I don't want to switch that. So now here, so this will be the EU, right? So EU, and just like I said, I will keep this bound here. I want to use the X bound, right? So I'm just not writing that. Okay, so now so what is my EUs here? My EU substitute back, so will be e to the y cube, right? Now I can put my bound here is 1 and -1. So what is the final answer? Will just be the E1 minus e to the -1. Or you can say e minus 1 over e. Okay, so these are the three problems with respect to the plane curves here. All right. So the things here, the key points here is problem number 1 will just be basically substituting into the formula. And the problem number 2 is to teach you how to do a line segment, how to find the parametric equation for the line segment. So we go back to our calculus 1, the chapter 12. We talk about how to define the line in the space. You need to have the directional vector. Then you choose a point and then put a parametric form or symmetric forms, right? So that is where we be able to use what we learned in the earlier calculus 3 class. This is what we said is the parametric form. So the number 2 teaches us how to do a parametric equation. Then problem number 3 is we'll talk about when we integrate, we can integrate respect to the arc length, or integrate respect to x, integrate respect to y here. All right, that's it. And now my next video, we're going to talk about how to do the line integral over the space curve. That means this curve is in the space right now. All right, that's it. And hope this will help you to do some of your homework problems here, right? Okay, bye.